Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello, everybody. Welcome to another episode of Master the NEC, where I talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host as always, and welcome to our podcast. On this episode, it might be a multiple-part series. To be honest with you, I hadn't made my mind up yet. I kind of make it up as I go. If you're familiar with the podcast, we talk all kinds of aspects of the code, some personal things, kind of keep it interesting. But I did get a request from somebody to talk about box fill and some of the key things with it. And of course, I could get real deep into this. I mean, I'm talking how to do splices and conduit bodies and all these type of things. And I figured I would do that. But again, this could probably go on for hours. There's a lot of stuff that actually in 314. So if you haven't guessed it yet, we're going to be talking about Article 314. So there's so many topics in 314 that I want to break it down. And so I figured I would talk about some of the general things. We'll do them shorter. That way you got something to listen to. And we'll cover all different types of topics. And I'll make it very clear about what topic we're talking about. Okay. For example, today we're going to talk about metal boxes, plastic boxes, volumes, and we're going to talk about markings and capacity and things like that. And then we're going to leave it at that. And then, of course, at that point, then we're going to get into the fill requirements and how you perform those type of things. But I want to break it down to make it easier for people to understand what we're talking about. Because the root of the question is, how many wires, how many devices, what can I put in a device box, 4-inch square box, 4 11/16 box, octagon box, what can I put in there, and how is it different based on the size of the conductors? Now, today's episode, we're going to deal with 18 gauge through 6 gauge conductors, the 6 gauge being American wire gauge, and specific sizes. And we're not going to deal with 4 gauge and larger in this episode, which is when we're going to kind of move up into 314.28, and that's dealing with the straight pull, angle pull, U-pulls. And that is a calculation that we need to do to determine what the width, the height, and the depth of the box is, based on the raceway sizes, the number of raceways, and the size of the conductors, and all those type of things. That is a beast in itself. I will remind you that we will have videos and all this, because there's some people that simply learn through video, and there's some people that really can gather the information through this podcast. I've got both. I get hundreds and hundreds of emails a month. It seems to me, believe it or not, I get more requests for the podcasts, and I would think that the video would be easier to follow. But people seem to like to listen to the podcast in the car, or at work, or as a group, or whatever. So, hey, I like doing the podcasts. It seems pretty simple, but, you know, we're going to go with that. So, but do look for some videos coming on the subjects as well. Those are very graphic detailed, and I'm in the middle of making a bunch of graphics, but I've also got other projects going on. So it's just a matter of prioritizing my time, and I'm not a very good manager of time these days, it seems. So, but let's talk about today's topic. So the first thing we would have to do is get the basic fundamentals of what 314.16 is all about. So the first thing that I generally do, I'm teaching a class on box fill and all this type of stuff. I take the class to 314.16 and I read the entire opening statement of 314.16. Now that section starts to lay out the concepts of how we're going to use 314.16a and how we're going to use 314.16b and the associated tables that go along with that, which are referenced from those specific sections. Okay? So, or subsection or subparts or sub-items, whatever. So, Even I don't spend all my time looking at the manual of style to understand how that flows. I is what it is, right? So we'll look at each aspect of that. There's somebody out there that I know is listening go, no, Paul, that's the part, subsection, sub-ID, item number, whatever. Okay? Whatever. All right, so let's look at it. 314.16. What does it say? It says the number of conductors and outlet, device, and junction boxes, and conduit bodies. The conduit bodies we're going to leave to a separate episode on its own. That gets deep in some changes that took place, so we're going to talk about that separately. We're going to focus on the aspects of outlet boxes, junction boxes, device boxes, and things like that in this episode. Okay, so first things first, that's what it says. So let's read what the code says. It says boxes and conduit bodies shall be an approved size to provide free space for all enclosed conductors. It says, in no case shall the volume of the box be calculated as calculated in 314.16a be less than the fill calculation as calculated in 314.16b. What does that mean? Well, the B component tells you all the things that go in the box, what value they have as far as a cubic inch. The A describes the different boxes and how you achieve what that box's volume is based on cubic inches. And so you have standard boxes, metal standard boxes that are listed in a table. And then you have other boxes which are not listed in the table, and that, of course, would encompass also non-metallic boxes, because the non-metallic aren't listed in the table that's associated with the metal boxes that are considered standard, off-the-shelf type of boxes. So you have to have the guidance of the two, okay? So that's where we're at with this, all right? Now, also in this, it reminds you that, hey, not only do you have this aspect of it, but if you happen to have conductors that are 4 AWG or larger, guess what? Remember what we talked about earlier, 314.28? You're going to have to meet those provisions as well. And again, jot that down because we're going to talk about that in another episode. In this episode, our conductors aren't larger than 4, so we're firmly rooted right here in 314.16. We're not going to go from that. Okay. Now, we will venture out to look at an aspect in 300.14, which is free conductor. But really, when we're talking about box, we're stuck right here in 314.16. We're firmly planted here. Okay. So let's kind of look at A, because we've been talking about A, and A is dealing with the box volume calculation. How do we determine what the volume is in that box before we even get into B, which says, okay, let's do that calculation based on what you're shoving into that box. What do we do with the box volume count? Where does this come from? So if you look at the A, which is 314.16a, here's what it says, and we'll discuss it. It says box volume calculation. It says the volume of a wiring enclosure, and it has boxes in brackets here, parentheses. It says should be the total volume, or shall be, I shouldn't say should, bad word, shall be the total volume of the assembled sections and, where used, the space provided by plaster rings, domed covers, extension rings, and so forth that are marked with their volume and are made from boxes, the dimensions of which are listed in table 314.16a. Okay, let's translate. So we have standard volume boxes and everything that is listed in table 314.16a, but we also have things like plaster rings, domed covers, extension rings, extension covers, all of these that actually will have a volume to them. They give you some more space, not just the space that's in the box, but it's literally giving you a little more space. Okay, so in that aspect of it, we can take into account that additional volume. But they have to be marked for that. So in order to be able to utilize that additional volume that you get from a plaster ring, extension ring, or whatnot, then we have to have that marked. Now, if I have a 4-inch square box and I have a 4-inch square extension ring, and it is identical to the 4-inch square box that is shown in table 314.16a, then that extension ring, it gets the same volume that box got, okay, by virtue of that. And it doesn't have to have anything marked on it. So if it was a 4-inch square and 4-inch square by 1.5 inch deep, then it was, say, 21 cubic inches. Then that extension ring is identical to what's listed in that table. All it is just has an open back on it. Then that would also give me an additional 21 cubic inches. So I'd have a total of 42 cubic inches if I used that extension ring. If I used a plaster ring or extension cover or whatnot, then that would have the volume stamped on it, and I could add that to my volume, and it might be necessary if I need that extra volume. Okay, so that's kind of what it's saying. Now, it also goes on, there's a change in the 2017 code that reminds you that what if I have a 2-gang box and I put a divider in there for whatever reason, and I'm dividing it up. Basically, it's saying that guess what? That divider is actually taking up a volume of that box. So now in the 2017 code, if you're new to the 2017, there is actually a volume that you have to take into consideration. Now, this volume has to get, it's portioned out to the separate space, okay? And they call it, the word they use for this is they use the word apportioned. Now, apportioned means to divide it up equally, like a pie, divide it up between the two spaces. I find the easiest way to do that is just take the total volume of the 2-gang box, and then look at the divider, subtract that out, that volume, take it away from the box's overall volume, and then whatever you have remainder, then you divide it by the number of spaces or number of gangs you have, and then that you take each space and treat them separately. That's how I do it. But what it says in the code, it says each barrier, if not marked with its volume, so it could actually have a volume marking on it, and then you would use that value. But in lieu of that, we have some values that are given to us in the code now, and that is if it's a metal divider, then you use a 1/2 cubic inch, and if it is a non-metallic divider, you use 1 cubic inch, so either 0.5 or 1.0 cubic inch, depending on whether it's a metal or it's a non-metallic. So basically, like it says where the box is provided with one or more of these more securely installed dividers, so it's securely installed, the volume shall be apportioned to each of the resulting space. Okay, so you can do it after or you can do it before. Your real goal is that you need to determine what the volume is for each newly developed space because of that barrier. But yes, that barrier is going to take some volume. So you have to take that into account. Okay? I like my way method better. I go with the overall volume, subtract out the barrier, and then I apportionate it at that point. Is that a word? Apportionated? Yes, that is the word they use. And then I work from there for each space. Because I could have a device in each space. I have conductors that go into each one, that are used for each one of those spaces. So I treat them accordingly. Okay? Anyway. So, that's how it works out. So that's your general rule for the box volume calculation. So we come down further. Now we have an item 1 and an item 2. Now item 1 is standard boxes. These are your standard boxes that are listed in that little table here. Well, I shouldn't say little. It takes up half page. It's 314.16a. Now take a look at that table. Now that table is dealing with metal boxes. So I usually tell people in exams to highlight the word metal at the top of that table, because this isn't for plastic boxes. This is metal boxes. Now these are general standard sizes. If they meet these dimensions, the manufacturers do not have to put the volume in the box. Okay. Now you notice on the right in the center column it says minimum volume, because that's what these boxes would be, minimum volume. Although the manufacturer can make this same box and probably could get a little more volume. And if they do that, and it's the same dimensions as listed here, then the manufacturer is required to stamp it in that box because it doesn't correlate with what's here. This is a minimum volume. If he wants to get more out of it, wherever, based on however they design their box, but the dimensions still fall within this table, This table is only if they don't want to stamp it in these standard boxes. If there's more volume, for example, I'll make it simple. Look at the square box, 4 by 1.5. It's 21 cubic inches. But what if the manufacturer provides me a 4-inch box that's 1.5 inches deep that actually they have stamped in it 22.5? Do I have to use a 21 or can I use a 22.5? Well, since they marked it and stamped in it, I get to use the 22.5. I mean, they're the manufacturer. They know, right? So that's what this means. So if it's not stamped and it's one of these standard sizes, then this is the volume that I have to go with, 21. So that's how it kind of works. Okay? So that's standard boxes. Now, what about other boxes other than the ones that are listed here? And that would include non-metallic boxes or any other box, metal, that is 100 cubic inches or less and that are not described in this table, 314.16a. Then I have to have the actual volume stamped or marked durably and legibly inside of the actual box. Okay, so all non-metallic boxes are going to have a volume stamped in it. Just got to look for it. Usually it's all the way in the back. And then the metal ones will have it printed on it. Usually it's just etched in it. And then again, if it's a standard size, it's probably not going to have anything. But if it's somebody develops a box that meets the same dimensions, but it actually has, let's say one manufacturer wants to game the other manufacturer and they know that all their boxes are standard, they make the same dimension of box, but they can get an extra 1.5 cubic inches in it, then they're going to stamp that in their box and they're going to promote their box as giving you an additional 1.25 cubic inches. Why is that important? Well, an additional 1.25 cubic inches might not do you any good. But if they stamped it with an additional 2 cubic inches, then that would be another 14 gauge conductor I could get in that box. Okay? So manufacturers, we're always looking to put our product one step higher than the competition so that, if it's a box that's other than the standard, but it's the same dimensions, then I got to stamp it, put that in there. Now, that's pretty simple to understand. What about when we're dealing with non-metallic boxes? So in a non-metallic box, we're going to have to print in it, emboss in it. Usually they melt in it the actual cubic inches. Now, typical nail-up boxes, 18 cubic inch, 20 cubic inch, 21 cubic inch, 22 cubic inch, whatever it would be. 4-gang boxes are going to have it stamped, whatever the cubic inches are in that box. Okay? That's required for the non-metallic boxes. Okay? And we'll work through that as we go through it. Okay? We also, again, I've already covered the plaster rings and extensions and all that kind of stuff. Now, the only thing I want to talk about is additional markings. What about those non-metallic boxes that also have those little verbiage in there? I'm sure you've seen them where it says 9/14 or 8/12 or 7/10. And you're wondering, what in the world is that all about? Well, that is the number of conductors of that gauge. So in other words, 9/14s or 8/12s or 7/10s can go in this box when there's no device being considered. This is just the number of conductors that I can put in this box. And that's it. Okay? So for example, I could have 9/14s. I could have 8/12s. I could have 7/10s. Maybe they're all just splicing in this box. The wire connectors, like a wire nut, which is a trademark of Ideal, by the way, are not counted. They're not in our device item fill list, if you will. So they're not really accounted for. Yeah, they take up volume, but it's minuscule in the realm of things. But so that's basically that in the back of the box is telling you how many individual conductors could go in this box. That's what it's doing. That's what its premise is all about. All right, so is that a requirement to have that additional information? Absolutely not. That was started by one of the manufacturers years ago, and then it seems like all of them follow. But again, that's the maximum number of conductors that go in there. But that's not with any fitting consideration, not any clamp consideration, not any device considerations. And usually since it's in the plastic box, it means that your connectors are not accounted for anything, because usually they're just a push in or you break a hole or something. It really doesn't take up any volume, so you don't have to consider those. Okay. So if I had to give you an example how this works, Let's say I had an 18 cubic inch nail-up box. Typically what we put in a residential, we nail these things up for the receptacles and switches and whatever. Let's say it's just going to be a splice box. So I've got 3 12-2s coming into it. Non-metallic sheath cable. I got 2 from the top and 1 from the bottom. Okay. So what we've learned so far, we have a black, a white, and a bare in each one of these cable assemblies. They come into the box. So how many conductors do I really have here? So I've got a black in each one of them, a white in each one of them, and I have an equipment ground in each one of them. Well, what we know so far is that the white counts as 1 for each one entering because it originates outside the box. The blacks, I'll count each one of those because they originate outside of the box. And then we have 1 equipment ground, which does originate outside of the box. So we're going to deal with the equipment ground last. Let's deal with the conductors. So I've got 6 conductors that enter this box. There's 3 blacks and 3 whites because I have 3 cable assemblies with 2 conductors and equipment ground in each. Well, when we went down and looked at the table, now we're trying to calculate volume. And 314.16b says that a 12 conductor has a volume of 2.25. Well, since I have 3 whites and 3 blacks, that's 6. So I go 2.25, because that's the volume for 1, times 6, and that is 13.5 cubic inches. Okay, that's the first number you're going to write down. The next thing you're going to say, well, what about that equipment ground? Well, here's where we got to jump a little bit. I want you to go all the way down from B. I want you to go to 314.16b, and you're going to go down to 5. Now, item 5 says that equipment grounding conductors, where 1 or more equipment grounding conductors or equipment bonding jumpers enter a box, you only account for a single volume allowance. Now, it is going to be based on the largest equipment ground in the box. Okay, in our case, they're all 12s, so it's based on a 12. So it's just 1 volume. So while I have 3 of them entering the box, they're only going to count as 1. And any jumper that I might have over, if I did have a device, would still only count as 1 total. Even if I had a metal box and I had to bond the box, that's equipment bonding jumper, it still only would count as 1. So even if I tie all of those equipment grounds together, they're still only going to count as 1 conductor. So now, let's rethink this. How many conductors do I have? I had 3 whites, I had 3 blacks, but all of the equipment grounds only have to count as 1. So how many conductors do I have? I started out with 6, add that 1 equipment ground, even though we know that 3 of them enter, we're only counting as 1. Now I've got 7 conductor count. And so in that case, I did the same thing. I did 2.25 because that's what the 12 gauge is as far as the volume allowance in table 314.16b times 7. And that is 15.75. Again, 2.25, it's just that simple, times 7 is 15.75. Can I have 15.75 in an 18 cubic inch box? Absolutely. So I put my wire connectors on there. Many people, again, refer to those as wire nuts. It's a trademark from Ideal. They are truly listed as wire connectors. As you see them listed in the allowance of 250.8. Gives you the different type of connections that you can be made. And they don't get counted. Okay? A little tidbit. I see a lot of people, let's say I didn't have a jumper here and I used the 3 equipment grounds. I'm just going to splice them all together. And I use one of those greeny wire nuts. Okay? Or those greeny wire connectors that has a hole in the end. If I don't have a jumper that comes out of that, theoretically, that would be a violation because the connection in accordance with 110.14 or the splice is not totally sealed. There's an opening on the end. But I don't have a conductor coming out of it. So technically, a lot of jurisdictions aren't going to let you use the green one. Or any of them with a hole in the end of it. Doesn't necessarily have to be green, but usually they are green. I'd have to use a regular wire nut because it's totally insulated. You don't have an opening in the end. If I have a conductor coming out of it because of an equipment bonding jumper over to a device, then that's different. That there isn't any openings. That's just coming out of it. May be nitpicky, but I have been in jurisdictions where they fail that because it's not substantially equivalent to the insulation. whereas a wire connector covers the whole conductive component up, okay? And the greenie with the open end on it, the little hole in the end, doesn't. Something could poke into the end of it. And it happens when you got all these wires jammed in a box. You never know, okay? I'm just saying. Some jurisdictions will frown upon that, okay? So there's just something to think about. Okay, so we covered the fill and everything like that. Now, some people say, well, can I use this? How can I use this number in a box to equate devices and stuff? Well, just remember that when we get to devices, the volume is what's called a double allowance. So you're going to take away 2 conductors from the number that's in that little thing that's stamped in the back of the box for every device. Okay, so you're going to have to physically to do that. And if you want, just remember, it's easier to just ignore these little cheats that they give you in the box and do the calculation yourself based on the steps that we're going to go through here in a second. Okay, it's the easiest way to tell you that. All right, so let's kind of go back up. So we know how to count the conductors. We've done that. Now let's talk about clamp fill. What is clamp fill? Well, if you've ever seen metal boxes that have the clamp inside of it, it's called an internal clamp. Now, it can be either factory supplied or it could be a situation where you are going to add something in the field that's designed to work with a device. Maybe you have multiple boxes that you're ganging together, and so you get to add an internal clamp. If that's the case and it's an internal clamp, that is counted as one conductor. And it doesn't matter how many clamps you have in there. As far as the volume, it's counted as one clamp. Okay? Keep that in mind. Now, if we segregate out the different gangs and we have dividers, then you treat each one separately. If there's no dividers, then you don't. You just treat the gangs as one. Okay? Try not to make it overly complicated with that. Most of the time, you're not going to have all these separate dividers, and you got to remember all of the rules that we just followed when we're talking about dividers in the application of 314.16a. Okay, we're going to keep it simple here today and just say, look, we're just dealing with a box, we're dealing with the openings, we're dealing with clamps, and the code says where one or more internal cable clamps, whether they're factory or field supplied, are presented in a box. It says a single volume allowance in accordance with table 314.16b, and that's where it tells us that's based on the largest conductor that's in the box for that clamp. Okay. So when it says that we do that, we take the largest. Now, let me use the same example that we just did a minute ago. What if we have a metal box and we have the same scenario? We have the 3 12-2s going into this box. And it's the same, let's just use the same 18-inch cubic inch box to see what's going to work it out here. No devices in it yet. We got an internal clamp. So we got the 2 coming in the top. We got the 1 coming in the bottom. It's a metal box. It's got the internal clamp with the little set screws in there, that clamp it down. We got our non-metallic coming in there. It's extending in there 1/4 inch. We're meeting the code. We're all happy. And now we have to account for the volume. And we've already done that with the conductors that we did. We said we had, the total is 7. Remember, we had 3 whites, 3 blacks, and 1 equipment ground. So we already did that, and that gave us 15.75. Now, we have these internal clamps. They get 1 volume or 1 conductor count. It's easier to try to remember them that way. 1 conductor count. So if they get 1 conductor count, then what happens is, it's based on the largest conductor that's in the box. So in our case, they were all 12s. So you're going to use 12. So the volume that gets, okay, is, if you go back to the code and you look at in 314.16b, you'll see that the 12 gauge is again at 2.25. So in our calculation, I've got that 15.75. Now I got to add that additional 2.25. So I'm going to do that and see what that gives me. That gives me 18 cubic inches. So I am right at the max. So, yes, I have a clamp at the top and I have a clamp at the bottom, but I only have to account for 1. So in this case, I would be compliant. Now, if I were to put anything else in this box, If I were to put a device in there, then we're totally screwed. And we haven't talked about devices yet. But as of right now, I am good to go. Okay? Everything's copacetic. I'm all code compliant. All right? So I just want to kind of keep us there without getting us confused. All right? So that's what you're dealing with clamps. Okay? Now, the only thing that else I should add is if you have a cable assembly, it's already a made cable assembly, and it happens to incorporate a cable termination for the cable connection as part of that cable assembly, and it's all listed together, like a whip assembly or whatnot, then that's all goes in. And if it's to be utilized with a non-metallic box, then it has to be listed for use with that non-metallic box. The other thing to say is that even though you might have this type of assembly, if the conductors still originate within the cable assembly, then you have to include them in your conductor fill, and so they're going to take up volume, obviously. So it's kind of like a raceway or cable coming into the box. You don't get to omit them. You have to calculate them in, so they actually count. So the whip conductors is a great example. They might enter the box from the whip or something like that. There are still conductors that originate outside of the box, so they have to be counted in our fill calculations. Kind of just a reminder with that. And so we already know that because that's what we did with the B1 for the conductors. We get that. This is talking about, you know what, if I have a clamp or cable assembly that includes all this and I connect it to it, then I'm only going to count for those conductors that enter into the box from that clamp approved listed cable assembly. Okay? Don't overcomplicate that. I'm trying to think of sometimes you have what's called a cable assembly that also incorporates terminations and everything as well in that assembly. And so if you have any conductors that actually originate within that clamp assembly, then you need to count those as if they entered from outside the box. Okay, so if any of those conductors that are part of that assembly, but the assembly itself is not required to have a fill allowance. But if any part of that actually stays in the box after the installation, then your question is what. And the code gives us the last guidance on that, and it says, look, if the volume of the portion of the assembly that remains within the box after the installation shall be excluded from the box volume as marked in 314.16a2. Okay, so you're going to exclude that from the box volume as marked. And in 314.16a2, again, as remind you, is dealing with the other boxes. Okay. All right, so we covered the clamps aspect of it. For an exam, for example, you really might have an internal clamp. It might say internal clamp. You're not going to get anything with any cable assembly, anything like that I would worry about. It's just the cable clamp, and you just need to understand it's a single volume. The next thing we would look at is what's called support fitting fill, and that's in B3. And what are we talking about? We're talking about Luminaire Studs or Hickeys. These are devices that actually, I shouldn't say devices. These are pieces of electrical equipment that actually support and hold luminaires and ceiling fans and things like that because of weight. And each one of these do take up volume. So they do count as one conductor, just like that clamp did. So treat them the same way if you have them in a box. Very rare today to see these in there. But if you did have them in there, then they're designed to screw on and support some weight. Some ceiling fans might have an application where some heavy ones might have some internal hickey or something like that. Okay, but again, they only count as one, and they count from the largest conductor that is in that box. If they're all 12, then you use a 12 volume. If you had 14 and 12 in the box, then it would be counted as the 12 volume. All right. The next thing would be the device or equipment fill. All right, so this is dealing with receptacles and switches and things like that. And you need to understand the concept of what a yoke is or strap. The yoke or strap is basically, the part where you mount it to the box, you have the screw holes. It's that metal bar or strap that actually holds the device. Now, a receptacle that has a single receptacle only is a simplex or single, where it has a regular duplex receptacle is two receptacles mounted on a single strap. Okay, so either way, that is considered one strap. You have a screw holder at the top and the bottom. Switch, you have a screw holder at the top or the bottom. You really look at the metal strap that supports that device, and that's what you're accounting for. And that gets what we call a double volume. And what do we mean by double volume? It literally counts as two. And let me tell you what I mean. So if I have a receptacle, and I'm putting it in that box that we were talking about, and I'm going to be taking 12 gauge to this receptacle. If I'm going to take 12 gauge to this receptacle, it's saying, okay, this receptacle takes up a volume, and it's a double volume. Double volume based on what? The double volume based on the conductor that terminate to it. So in this case, let's say it's 12 gauge terminating to it. So we know that 12 gauge based on the table 314.16b for a 12 gauge is 2.25. But since it's a double volume, then we just do that times 2. So for a device, if it was terminating to 12 gauge, then it's going to have a 4.50 volume allowance. And so I had to add that. So in our example, that box that we just had, which was right at 18 cubic inches, yes, you could probably jam that device in there, but you would be in violation of the code because I would be exceeding that 18 because we're already at the maximum. So I would exceed it by 4.5 cubic inches. So I need a bigger device box. So that would be typically a 22.5 cubic inch device box would work for me. Okay, that's how. Or maybe a 4-inch square where I'm going to have a raised cover plate with a single opening. Then I might be. Obviously, I'm going to be okay. Okay, in that aspect of it. Right. So, but I might not in a 4-inch square where it only has a 21 cubic inch. Okay, and I've already at 18. So if I go 18 and I need 4.5. Then I go 18 plus 4.5, and that's 22.5, and that was only 21. So I could be screwed there even with the metal box, and you would think that there's a lot of volume in there. So what would I use? Well, I might use, like we talked about earlier, I might use a plaster ring, I might use a raised cover in order to get me those additional couple cubic inches that will get me over that hurdle to be able to put that device in there. Kind of see where I'm going with that? Okay. So that's how you do it. You're trying to accumulate additional space. So that's how you deal with it. And it's basically 2 per yoke. So if a 2-gang box and I have 2 switches in there, it's 2 the volume allowances for each switch. Okay. So if I have 2 switches, then basically if they were 12 gauge going to each one of those, then it would be 4.50 because it's 2.25 times 2. Of a volume allowance that I have to account for each switch. Okay, same if it was a receptacle. Same thing. Okay. Now, if I'm doing a box fill and I got 14 gauge and 12 in the box, then that volume allowance for that device, okay, is based on the conductors that are feeding that device. Okay. Because it says here, shall be made to each yoke or strap based on the largest conductor connected to a device or equipment supported by that yoke or strap. Okay, so you just section it out. You do your calculation based on your 14 gauge conductors enter the box, and you do yours based on the 12. Remember, they're all just number values. You just have to do the adding it up, and you just have to remember that devices count for 2 times the volume, that hickeys count for 1 times the volume of the largest conductor in the box. The internal clamp counts for 1 times the volume of the conductor that enters the box, the largest conductor. So that's kind of how you work through it. And it keeps it pretty simple to do your volume calculation. Remember that pigtails do not count. Lock nuts do not count. Bushings do not count. Okay, grounding screws, okay, don't count. Equipment bonding jumpers don't count in adding to the volume. you have one equipment grounding conductor, no matter how many you have in the box, that you count as one. Okay, so we kind of covered that. Okay, a lot of people get lost on that, but they see 4 different equipment grounding conductors coming in there, and they go, "Oh, 4," and they end up making a box bigger than it needs to be, which is okay. You can always be larger, but we just don't want to get overly confused with how that application rolls out. All right, so that pretty much covers all of the items. Again, remember, the wire connectors, like a wire nuts, they don't count. All right? You don't have to take those into consideration. Every conductor that enters into the box, count. Every wire that passes through a box that is 12 inches or more in length, then it is also a double volume, because you conceivably could cut that in half and you have 2 6-inch pieces. And in accordance with 300.14, that's the minimum free space of conductor that enters into the box. If that's the case, then I have to treat each one of those conductors. But if it's a 12-inch piece or more, then I'm going to automatically consider it as 2 separate conductors. So I have to remember that. If I have a loop that's passing through the box that is only, say, 8 inches long, it's simply coming in and going out, well, then I don't have to count that except for as one conductor. Okay? And that all is given to us when we look back at the rules that are in B1 for that conductor fill that we talked about. So if it's passing through the box without a splice or termination, I count it once. Now, if it's 12 inches or more, then I'm going to consider it as a double volume. So, what gets double volumes? Devices get double volumes. What did I just talk about? The loops that are 12 inches or more, that gets a double volume. Everything else gets single volume. The only other thing to remember for double volume is one we didn't talk about is what happens if we have a device box, or I guess, yes, a device box, and we have a device or piece of equipment that's going in there, occupancy sensor, whatever it could be, that goes in there, and it is wider than what would be necessary for a 2-inch device box. Okay, because if you look at the dimensions in 314.16a, you'll see device boxes. You'll see all of them are 2, so it's 3 by 2 type of thing. So you've got that 2, so we're talking width now. Any of the applications where you have a device that will require to go in a box that is that's wider than a single 2-inch device box, as described in 314.16a, and we just kind of talked about that, all of those device box listings, then what you're going to need to do is have a double volume allowance provided for each gang required for mounting. So if it's a range receptacle and it fits in a 2-gang box and it's fine, then it's simply a double volume allowance like a normal switch. If it's required to go into a 2-gang box and in order to be mounted, it's going to use 4 sets of mounting screws, another top or bottom, it's going to take up 2 gangs, then it's a double volume for each gang that it's mounted on. Okay? So in case that one would be a 4 volume, or a factor of 4. So if it was a double volume, it used 2 gangs because of how wide it is, and it goes into a box and it was 12 gauge going to it for whatever reason, just to say it was, or even 10 gauge. Let's use 10 because that's probably what you'd run into. Then it'd be, so the volume is 2.50. So it'd be 2.50, and since it's going to, if it utilizes 2 yoke spaces or 2 gangs in order to mount this box, then it would be 2.50 times 4. And that would take up 10 cubic inches of volume for that one device, because it is larger than a 2-inch device. It's not, it needs a box that's bigger than that, and it's taking up 2 gangs within that box. So that's going to require it to do that. Okay, so like it says, it simply says that you're going to account for a double volume for each gang that's required for the mounting of it. Okay. Now, don't get confused. If it's a dryer or range and it fits into the normal box and it's not larger than 2-inch device box and it fits in there fine, then you're going to do a double volume allowance because it's only mounted using that one yoke. Okay? Don't overthink that. That's just throwing that out there for you. Okay. So we've kind of covered everything that I wanted to cover here. You see how you simply add these components up. To do that, and it's pretty simple calculation. Just remember all these little components that come in. If I have a raceway, it comes into a box, and I have 3 raceways coming in. Break down each one of the conductors that come into each raceway. Now, some of them might be mutual with a loop that's running through them. Take that into account. If I have a neutral conductor that's coming in from each one of these and they go into a wire nut, that's okay. Just remember that each one of those neutrals originate from outside of the box, so they each get counted as one volume for whatever size they are. Okay? Pretty simple stuff here. All right? All right. So that's the end of the first part, the first episode. I had 45 minutes, a little longer than I wanted it to be. But I think we kind of covered the basics of box fill for conductors that are 18 gauge through 6, and all of the volume allowances, things that are stamped in the box, listings, and things like that. Later, we'll start getting into things like a little more detail about domed canopies and conduit bodies. That'll be the next one. We'll deal with that and kind of deal with that in a part 2. Until next time, folks, stay safe and God bless, and stay tuned for part 2 of this series.
Every day the future's getting closer. Every day the future's looking bright.